Hello, my name is Dr. Matthew Mitchell. I am Associate Professor in the Department of Health and Human Performance and also the Director of the Human Performance Laboratory here at Palm Beach Atlantic University. And today I get to share a continuation of a lot of the research we've done looking at subjects with autism spectrum disorder or ASD. And so before I get started, I really need to give credit to a few of our undergraduate researchers. A lot of this project was part of Alexis Brown. She's since graduated from our program, a part of her senior research, as well as that of Emily Headley, who is now continuing her graduate research in this area. So we're really excited to share a lot of the work they did as we continue to do a lot of our work with autism. So this study specifically, we're looking at the effects of neuromuscular training on improving plantar pressures and other aspects of walking gait in subjects with ASD. So probably would help to start with what in the world is ASD. So autism spectrum disorder is defined as a group of multi-system neurodevelopmental problems or disorders, typically characterized by impairments in social interactions, communication skills, and then typically there's going to be the presence of repetitive and stereotypical behaviors. And this can begin, we know this begins early on in life. There's signs that this begins early, at least the signs of it, at 6 months of age. And we see numerous issues from impaired motor skills, impaired balance, limits and effects on muscle strength and obviously cognition. And with this, which has been some of our experience, is increase in injury rates. We're really fortunate in our work to partner with the ELS Center for Excellence in Jupiter, Florida, where they have over 250 students with ASD. And it's, as we began this work a few years ago, I remember our first conversation, some of the anecdotal conversations we had were, gosh, if you just saw how many kids are falling all the time in our hallways, whether it's tripping over each other or walking in the walls or things like that. And the concern of, can we reduce that risk? And it all coming back to these impairments in motor skill function, cognitive function. And so a lot of our work is done in this area, trying to understand this better and then finding ways to hopefully potentially improve this. So there's been a lot of literature in the area of gait mechanics. And so when I use that word gait, we're talking about the means to which and the efficiency of which we move or walk. And so there's ample evidence that there is impaired control of posture, particularly around the trunk. And we've seen this in our data as well. And obviously that is going to affect not just walking gait, but balance during walking. There's ample evidence that gait symmetry, which basically is the walking cycles, both on the left and right side of the body, how similar they are. That's typically impaired. We know it's stride mechanics. This includes different parts of the gait cycle, swing phase, stance phase, double stance phase are impaired. And then muscle contractions themselves and the coordination of them. We know there is very specific timing of muscle contraction and muscle inhibition when we move. And we know that in individuals with ASD, there are impairments and irregularities in that. And so what we set out to do in this study is build on previous research we've done and see, looking at some of these abnormalities, can we use some type of neuromuscular or motor skill program to improve some of these indices? Let's look at a little bit at our methods. So in our methods, we're fortunate again to work with the ELS Center of Excellence. We had 17 ASD subjects in our study. Now, I will tell you, these were not necessarily randomly sampled. These were subjects who volunteered to be part of this program. And that, as we'll see later on, may have affected some of our data. Generally, these subjects were a little bit more on the mild or moderate side of ASD. We measure ASD by what's called the CARD score, which is a childhood autism rating scale. And on the average, these were a little bit lower on the scale than we have seen in our previous studies and work we've done. And as we'll see, that may explain some of our data. And on top of that, we actually partnered with the First Tee of the Palm Beaches because they were initiating a program looking at the use of golf and golf skills in improving both motor skill and cognitive function. And so we partnered with them and the ELS Center for Excellence to see, can a motor skill program that was specifically revolved around golf, can we see that improve any of these indices? And so the way the program worked is it actually lasted for 6 weeks. And this program involved stretching, some other coordination, warm-up activities. And then there were periods throughout this 45-minute session where the subjects were engaged in golf-related activities. Now, As many of us have probably played golf before, we can imagine what those are, from working on our swing, rotation of the tips, those things that if you've played golf, some of us probably aren't that great at. And that was the same in this group. But there was also a sizable focus on improving balance, maintaining postural dexterity, both in the trunk, the limbs, and the upper body. And there's definitely a carryover in that to walking and other movements. And our hope was to see, would we see a carryover of improvements in that area to improvements in actual walking and other aspects of gait. And so then what we did is, before and after these 6 weeks, pre and post, we looked at a number of measures to assess gait function. One of those is measuring what we call plantar pressures. And basically these are pressures on the plantar side or the bottom side of the foot. And we have a walkway, it's called a P-Walk walkway, it's about 1 meter long, and it's portable, so we actually brought it up to the L Center in Jupiter. We have our subjects walk back and forth along this platform, and allows us to assess partial pressures actually to the square millimeter of every aspect of the foot. So it gives us really good information, not just how much pressure they're showing, but specifically on what bone, and even not just on what bone, but what part of the bone. Pressures on the calcaneus and the metatarsals, we can really get precise with some of those values. And so we measured this both in standing, what are called static pressures, and then we did this while they were walking, which are called dynamic pressures. So along with that, and this is kind of a picture of what these pressures look like. This is more of a colorful, pretty version of it, and kind of gives us an idea where the more red areas are going to have higher pressures, obviously, and then the bluer, more green areas tend to have lower pressures. Along with that, we also wanted to measure different aspects of gait. We call these gait kinetics, and we used a G-Walk G sensor, and basically this is a high-end triaxial accelerometer. They've actually attached to the S1, S2, sacral one to lumbar sacral spine, and allows us to measure really minute changes as an individual is walking in their trunk. And we can measure these changes in both the X, Y, and the Z axis, and it gives us really good information of what's going on in the entire spine. We know because that is then connected to what's going on in the lower body as far as gait mechanics. And when we got this data, and I'll go through a lot of the data that we obtained, we did dependent t-tests on the number of our variables, looking at the group means between pre and post. And because that we had such a large amount of data, we actually did a false discovery rate post-hoc sampling, specifically a Benjamin-Hochberg analysis, to limit the type 1 errors we had in our data and get precise, hopefully accurate assessment of which of these variables was significantly different. So what did we find? Well, our findings, I will be honest, were a bit mixed. For one, we did discover that our group was definitely a little less on the autistic side than we had expected. Their body composition, height, weight were fairly similar to what we'd seen before, and actually fairly similar to normal age-matched controls. What we were really interested, obviously, though, was more of the pressure and gait parameters. Let's start off with balance. Well, what we found was that after 6 weeks of this training program, there were no significant differences in measures of balance. And we do this by measuring center of pressure, or COP, which basically is when a subject is standing still. They do this for 5 seconds. We can actually measure the center of pressure. It's a dot, quite literally, and we can measure its distance, its speed, its acceleration. And there was no differences in any of those values from pre to post. So we were a little surprised by that. We had seen that this was a key marker in separating severe versus moderate autistic students. This balance, particularly center pressure, was far different in those groups. But in this group, with the training, we really did not see any differences. So let's go on to what we call spatio-temporal values, or more values we look at while someone's actually walking. Well, what we found was that there was also no significant difference in the gait cycles. This is the amount of time we spend in swing phase, which is when a leg is swinging in the air, stance phase, both one leg stance when we have 1 foot on the ground, double stance when we have 2 feet on the ground. There was no changes in those values. And again, I want to say we're a little surprised by that, but a little different than what we had seen in some of the previous literature. We then also, to get a little more advanced, wanted to look at how does the trunk move in the X, Y, and the Z axis. And so the way we do this, we actually take our data from someone when they're doing a walking analysis, and we compare their data to someone similar age, a similar height and weight, and take their data and compare it to that. And so we consider normal to be 100%, and everyone else scores as a fraction of that. And so the higher score you have, the closer to 100, the more normal you are. The farther away from 100, the less normal you are. And we actually found in most of our variables, there was not a significant difference between pre and post, both on the left side and the right side of the body, in what we call a symmetry index. In other words, when they were walking on their left leg and their right leg, were those values similar in the x-axis, which is our tilt axis, our y-axis, which is, we call it our obliquity axis, or our rotation axis, our z-axis. There was no difference in any of those. And again, a little bit surprising. This is another area that we had seen significantly different previously when we looked at severe versus moderate autism. However, where we did finally see some differences, and this is something we had seen previously, was in plantar pressures. Now, one thing to understand about ASD is after you see or around ASD students, you start to pick up on some patterns. And one pattern that many of us pick up on is that we often call students with ASD, we call them toe walkers. I use that term because they often walk on their toes. The normal walking gait, and I'll kind of use my hand as this, we walk, we land on our heel, we move to the outside lateral side of our foot, then we push off on our toe. And that's a normal walking gait. Typically in moderate and even severe ASD, there's often very little or none at all heel strike. And so we call them toe walkers. They tend to walk a lot on their toes. Now the problem with that is the pressures then become much higher on the forefoot. The balance is far less, and then the potential risk for injury is far higher. And so we had seen that this is a big difference between severe and moderate ASD. Previously, toe walking was a big difference. And our hope was, could we see this training program improve that? And we did. We actually did see some significant differences, more on the left side. It wasn't statistically significant on the right side. We saw movement away from pressures on the metatarsals, more on the forefoot, and towards more of the calcaneus on the rear foot. And we're really excited about that. Not just the pressures, but actually the surface area as well. So they actually were making more contact, not just more pressure, but more contact with their forefoot after this program than before. And that was exciting for us to see that difference in both the surface area and the pressures, and something that we're looking forward to build on. In fact, because of the accuracy of our devices, we could actually pinpoint significantly that the biggest changes in pressures were actually on the first, second, and third metatarsal. That's how specific we could be. And that's actually very helpful because we know it's those metatarsals that when we walk, we tend to push off when we go back into swing phase. And that's actually a good thing to see pressures to move on that side of the foot. So really excited about some of those findings and finding those significant. Okay, so overall, what we found was that following 6 weeks of neuromuscular training, that there were some limited significant changes in gait mechanics, specifically changes in pressure and surface area on the plantar side of the foot. Again, excited about that, and that's a marker we had measured before in our laboratory. Unfortunately, we didn't see significant differences in other kinetic measures and other spatio-temporal measures that we had hoped to see. Now, some of the, I guess, delimitations of our study, and we were well aware of this as we were going through this. Our sample was perhaps not a great sample of the wider range of ASD subjects, particularly at the L Center. We definitely were a little more limited as far as moderate, more mild ASD cases. And that is significant. When we typically see more impaired motor skill function and more impaired gait mechanics in severe ASD, it would logically make sense that potentially a program may be more beneficial to that group and less beneficial to a mild ASD group. And there's probably merit to that. The training program was not one we devised in partnering with the first tee of Palm Beaches, but that's okay, we're excited to be part of it. But it didn't necessarily have a really large motor skill component that we've seen in other studies, and it didn't specifically focus on walking gait or other movement patterns like that. So in the future, and it's our next step of this work is seeing, can we devise some training that will specifically look at that? And then the inconsistency of our data. Again, we saw some changes in pressure, but not in some of the gait cycles, which was a bit disappointing. So it does make it a little bit hard to make precise conclusions on what we found, aside from that there seems to be a slight improvement, but in most areas, not necessarily a significant improvement. So thank you. It's really been our pleasure to share this with you and a lot of the research we're doing with autism, and we hope you enjoyed our presentation.